Okay, here is a video. I'm going to walk through this first example in the textbook from chapter 3, which is refrigerators. So, the book is talking about forecasting, and it gives the scenario, what if the appliance store sells exactly 10 fridges each week? Also, the manufacturer delivers 10 each week. What would they order the following week? Exactly 10. But that doesn't really happen in the real world. And they walk through an example here of weekly demand for refrigerators in the last 100 weeks. Question is, how many refrigerators should the store order for the next week? What I've done is I've downloaded the demand data from Canvas, and we're ready to use this demand data from the textbook to answer this question. How many refries, refrigerators should the store order for next week? And let's just follow the book here as we go down. The answer depends on what the demand is going to be. As the data show, the demand in each week the last 100 weeks was somewhere between 3 and 19 units. So if you look at this demand, the lowest was 3, the highest was 19. Further, it's not easy to predict what the demand will be next week. So to make a better decision, we must do some estimates, develop an estimate, a forecast for next week demand. We're going to create a model to help us do that. So let's go ahead and go to the next section here to help us understand three different models that we can make with this data. First, there's the empirical distribution model, and they have created a histogram of this data. We have demand on the x-axis and frequency on the left. So the demand for 8 fridges happened 16 times over the course of those 100 weeks, is how to read that chart. Um, One approach is to use this frequency histogram for our modeling, and this represents the actual data of past demand. It shows which demand occurred more often than others. 8 occurred 16 out of the last 100 weeks. 10 happened 13 times over the last 100 weeks. And this is how we can develop some probability for these demands. So what we can do is we can develop a empirical probability using our demand value and the frequency of those demands. So let's create a histogram chart using the data that we have here. What we'll do is we'll go on to our data tab, we'll click on data analysis. If data analysis is not showing on your data tab, you can go to File, Options, Add-ins, click on Go, and check the option for Analysis Toolpack at the top. If that's selected, click OK, and that should show up inside of your data tab. Data analysis, once we click on that, we'll click on histogram. And before we do that, we need to identify the bins that we're looking for. So let me cancel that. And all we're trying to do is reproduce this visual in our Excel. The bins here are simply individual demand from 1 to 19. So why don't we do that? We'll do 1 to 19 just across the top here. That will give Excel an idea of what we want our bins to be. Now that we have our bins, we can come in here to data analysis, select histogram, click OK. The input range is going to be our demand, starting with week 1 all the way down to week 100. The bin range is going to be the bins that we just created, 1 through 19. I'm going to output this to cell D5 right here on the same sheet. And then I do want to click on chart output. If we do that, what we've done is we've created this histogram. So we now have a histogram that displays the frequency of these demands by week, which is right here. And what we can do is we can take these frequencies and we can create a empirical probability and cumulative probability. So let me go ahead and move this chart down or move this down here a little bit so we can move this one over, do a little bit of moving around, shuffling around our pieces here. And we can use this output that we just created. Let me just move this over one more here as the starting point for our empirical probability and our cumulative probability. So we have our bins and we have our frequencies. So how do we go from frequency to probabilities? This is going to be our empirical probability. And the way we'll calculate this is we will say, what's the probability of this frequency in the overall frequency of 100 days? So we'll do E20 divided by, and I have a habit of not referencing my cells. I'm just going to reference this. If I wanted to be really cool, I would select this and say, give me the max. And that would also give me 100%. And what we're doing here is we're creating a max. We're asking for the max so that we can create the empirical probability for each one of these frequencies. I'll copy this down. And just like we mentioned before, the demand of 8 happens 16 times over the course of 100 weeks. And so that empirical probability is 0.16. We do a little bit of formatting here. And that is our empirical probability for each of these demands. Here's our bins. These are keeping track of how many times we have demand of 8, how many times we have demand of 10. And this gives us our empirical probability. Our probability, cumulative probability is um, the cumulative. We're just going to add these together. So I'll take the cumulative empirical probability and I will add that up. And that should equal to basically 100% once we're all done. So here we have the empirical probability. We have the cumulative probability. We really don't need this line down here. There's nothing more after 19, so I'll just go ahead and delete these just because that gets us to 100 here at 19. There was once where there was 1 week where there was a demand of 19. So what we've done here is we've created a histogram. We've created an empirical probability for each one of these demands, and we've created a cumulative probability so that if we wanted to ask ourselves the question, what is the probability of demand in a week being 8 or less? We know that through our cumulative probability, using this empirical distribution, that 8 or less would be 0.45. That's our cumulative probability distribution, that we would have 8 or less demand for refrigerators in the future. The textbook states empirical probability distributions are useful when the number of weekly demand is not large. Okay, so these are not large numbers here, right? 3 to 19 are not large numbers. As the number of possible values increases, it becomes more and more difficult For example, suppose the weekly demand for fridges ranges from 100 to 1100. In this case, the histogram would include 1,000 values for demand, right? 1,000 columns going this way in the histogram. But that's not the only problem. It's also more difficult to develop analytical models when demand is modeled by empirical distributions. Due to these difficulties, empirical distributions are often approximated by well-known distributions that have more tractable structures and are easier to work with. So when these numbers get too large, there's other models. Two of the most common are the Poisson distribution and the normal distribution. So let's go to the Poisson distribution. What does that look like? Let me just go ahead and label this as our empirical distribution. And let's come down here and create another distribution. And let's look at this one, Poisson. One distribution is often used for modeling demand is Poisson. Poisson random variable represents the number of events in a given period, so number of sales in a week, or the number of defective items in one shift. This distribution is characterized by only one parameter, that is lambda. It's greater than 0. Has the probability mass function as follows. So here's their probability mass function. It has a mean of lambda and a standard deviation of the square root of lambda. To use Poisson distribution to model the demand, first we find the estimate for the Poisson parameter. Remember or recall that the lambda is the average demand in a period. So let's look up the average here. What is our average demand? Actually, let me put this right here. Average demand is equal to, and I'm going to type in an average formula. I'm going to go all the way up to the top and I'm going to average my demand. What is the average demand? So my average is 9.25. Let's see, it might be helpful to have the formula text here. Okay, we have the average demand. This is an estimate for lambda. And here, what they've done here is they've calculated the lambda at 9.25. They're going to plug this into the formula to find out what is the probability of demand in a week that is 10. So they're going to put in this formula here. Luckily for us, we can use an Excel function. So let's do the Poisson function and let's look at 10. What does that look like? We're going to do Poisson. We'll do the dot distribution. This is the newer version. This is the old version. And our X here is 10. In fact, let me do this. Let me go ahead and put 10 here. Move this down so I can reference that. The X is 10. What's our mean? Our mean is 9.25. And the question is, are we going to do cumulative or are we going to do just the probability mass function? The probability mass function is just at that 10, at that X level. The cumulative distribution is everything else underneath that, including 10. So in this case, we're asking X being 10. So if X is 10, we're looking at the probability mass function, not the cumulative. So we're going to select false for this third option here in our Poisson formula. And it says Excel returns the value of 0.121. There it is. So we have a value of 0.121. Okay, so far so good. Now, if you look at the graphs here in the book, interestingly enough, the Poisson distribution is a good approximation for the weekly demand refrigerators. Look at that. There are some outliers here. 8 is pretty high. 6 is high. Maybe 11 and 12 are a little bit low. But overall, it's a pretty good approximation, which is cool. Okay, so then they say, let's take this to the next level. Let's do look at cumulative, which is asking, what's the probability of demand being 10 or less? How do we compute that? What we can do is we can use our very similar formula that we just used. This is going to be Poisson at 10 or less. What is that going to be? And we'll use the Poisson distribution. X is still 10. The mean is still 9.25. This time the cumulative is true. We'll select the true option here. And that is right here. Now, let's see, the book says 0.676, which is exactly what we get. Poisson distribution fits demand in many situations in practice. It's been shown if there's a large number of customers making decisions of when to buy randomly and independent from each other, then the demand in any given period follows a Poisson distribution. Interesting here, the language that they use when they talk about buying randomly and independent of each other, which fridges is probably independent, right? People are not hoarding fridges. It's not like toilet paper and everybody's buying at the same time. Everybody's buying randomly and independently. Okay, so the third distribution model here is the normal distribution model. And so we've done Poisson, we've done empirical, and now let's do the normal distribution. Here's our normal distribution model. Distribution model. And this one you may be familiar with from statistics. While Poisson has only one parameter, normal distribution has two parameters, a mean and a standard deviation. And here's the density function. Here is the mathematical formulas about how to derive this information, right? What we're most interested in is what does the normal distribution say will be the probability of particular demand for next week? So what we do is we use the above formulas, although we'll just use Excel and we'll create what the average, the mean is, and the standard deviation. We can do that relatively quickly right here in Excel. So this is our average demand. Again, we've already done this one. We'll do it again. We're averaging all the demand. It's still going to be 9.25. The other thing we're looking at here is a standard deviation. And we will use an Excel formula for that as well. I'll use the stdev.s for sample. And what is the standard deviation of this demand? 3.05. And if we look at the book, we have 9.25 and 3.05. So far we're doing pretty good. So far. Now that we have that, we are going to convert in, we're going to have some standardize the random variable z. We're going to do some standardization here. We get into some more deeper formulas of where this normal distribution is coming from. As we know, the standard random variable z is normally distributed with mean 0 and standard deviation 1. That's what standardization means, is we're putting all these distributions into the same scale, 0 to 1 being the first standard deviation. Then we have the mathematical formulas for the density function and the cumulative distribution. And we can see those there. And it also gives us the relationship between the cumulative normal distribution and standard deviation and the cumulative distribution of the standard deviation as follows. So here is the relationship. This relationship's important. It allows us to compute the probability of having certain demand values as well as cumulative probabilities for any demand values. Again, the math here is behind all of these equations that we're using. Suppose we'd like to use the normal distribution to approximate the probability that the demand for refrigerators in a week is 10. Because normal is a continuous probability distribution, but demand is a discrete random variable, the probability that discrete demand is 10 can be approximated by the probability that continuous random variable D is between 9.5 and 10.5. So what we're doing is we are estimating the demand at 10 because normal is a continuous distribution, but demand is a discrete random variable, 10. So we have to take 9.5 and 10.5 to estimate what that 10 is. And basically what we're going to do is we are going to find in Excel what the continuous normal random variable is at 9.5 and what the continuous normal random variable is at 10.5 and take the difference, and that will give us an approximation for the probability at the discrete number of 10. Okay, so the way we do that is we're going to define our x. Our x is now 10. So if we have our x is 10, we're going to find the normal distribution for the 9.5, and this is going to be cumulative. So this is going to be 9.5 or less. And the way we're going to do that in Excel is with our normal distribution formula. X is 10, our mean is 9.25, our standard deviation is 3.05, and we're going to do a cumulative distribution function. That's going to give us 0.597. But remember, we can't use 10 here. We actually have to use 9.5 instead of 10. So what we're going to do is we're going to change this. Instead of doing 10, we're going to use 9.5. So let's do 9.5 here. Actually, let's do this. Let's do 10 here, and then we'll do E56 minus 0.5, and that gives us 0.532. And we're following along right about here in the book, right? So we're not doing all of this. We're going to do all this in Excel. The book gives you the manual, kind of the long process, how it gets there. Luckily in Excel, we can bypass most of that. And hopefully this is helpful to try to understand what the book's actually talking about. Let's do our normal distribution. Our x here is going to be the 10, but in this case we'll do plus 0.5. We have a mean of 9.25, a standard deviation of 3.05, and then we have a cumulative distribution is what we're looking for. And we have a 0.658. And notice that the numbers here are a little bit off from the book, a 0.6554 and a 0.5320. This is due in part because, or all of it, because of rounding. So notice how these numbers are not rounded. We have some more decimals. We have some exact numbers that we're using when we're converting. We're referencing the average demand and standard deviation. And so the decimals here is what's giving us a little bit off. But these are the numbers that we're using that are close right to the book, right? 0.532, we have 0.5326. So now that we have these two, we're going to take the difference. And the difference between these two is going to allow us to approximate where that x is for 10. So we'll take the 10.5, we'll subtract the 9.5, and the difference is 0.1263. Notice the difference in the book, which is that approximation, is 0.123. So again, a little bit of rounding error here on the 0.126 to the 0.123. And that is the probability of 10 or less. The probability of having a demand of 10 or less for next week using the normal distribution model is 0.1263. There's one more thing here that the book looks at. And let's say it says, now suppose we'd like to find the cumulative probability that the demand refriges in a week is 12 or less. Again, since we're using the normal distribution, which is a continuous probability, to approximate the demand distribution, which is a discrete distribution, we do these steps. And in this case, what we're going to do is we're going to use that norm distribution again to find a cumulative probability of 12 or less. Notice that what we're doing here in this second part is we're saying we want to know the demand for refrigerators in a week if it's 12 or less. Our original question up here in this first part of the normal distribution is we were looking for a specific demand of 10. So it's interesting that when we're looking for a particular demand, in this case 10, we take the difference between 9.5 and 10.5. In this case, when we're looking for 12 or less, right, the cumulative, where we're looking specifically for a cumulative distribution, we don't have to subtract. We do a very similar process, but in this case, we're looking for um, that 12 or less. It is interesting to note that even though we're not taking the difference between 9.5 and 10.5 in order to get the 10, there is a correction we need to make because we're going from a continuous probability to an approximate demand distribution, a discrete district, like a single number. We do need to account for that continuous probability by adding 0.5 to the 12. So when we actually perform the calculation, the x that we're going to use inside of the norm distribution function in Excel is going to be 12 plus a 0.5. That 0.5 is going to account for this continuity correction. It's accounting for this normal distribution as a continuous probability distribution. So what we're going to do is we're going to find the cumulative probability of 12 or less. The way we're going to do that is we're going to use the 12.5. We'll use the normal distribution at 12 or less. And the formula is normal dist. X is 12.5. Our mean is still 9.25. Our standard deviation is 3.05. Cumulative is actually going to be true. We're doing 12 or less at 12.5. And Excel returns 0.856. And again, that's a little bit off from the rounding from the book of 0.857. This is what this means. This whole section has been looking at these three distributions: empirical distribution, Poisson distribution, and normal distribution. And how do we build a model and predict what the demand is going to be based on each of these three different models? Hopefully this is helpful, and let me know what questions you might have. Thanks.